Okay, this question is a rates of reaction question. This was from paper 2. It's the only question from paper 2, and obviously I'll look to put more paper 2 questions in the next mock that you do. The question, first of all, talks you through a method, so make sure you read that carefully and understand what's going on. I'm not going to go through that now. I'm trusting that you can follow that relatively straightforwardly, and you've done that practical. The results were shown there. You can see the number of moles of gas. Moles we'll learn much more about next year, but it's just a way of describing the amount of gas that's produced. Right, so in question 8.1, some people just simply didn't do question 8.1, which lost you 3 easy marks, I would say, and you've got to draw a line of best fit. I'm not going to actually plot the graph in front of you because that will take forever, so I'll just pause it. But there we go, I've just added it in. Now you've got the first 2 marks for doing all 7 plots, and that includes the plot at 0, 0. Some of you did such tiny plots you couldn't see them, so you couldn't get the marks for that, and that might seem mean or unfair, but that's the way the GCSE mark these. You have to show the plots. You have to be really careful as well. You can see how they're testing you here. You can see that the units for time, or the grid lines for time, every 2 squares is 10 seconds. So you have to be really careful to get 30 seconds right on the right place, and 60 seconds right in the right place, and so on. So be really careful. And like on the number of goals, the y-axis, if you like, things go up by 2 each time. So 0.0011, for example, is halfway in that square there. You can be really careful and get that right for 2 marks. The next mark is to draw a line of best fit. Now, lines aren't always straight lines, as you can see from the one above it. So lines can be curves or straight lines, but the one that's needed here, this is a pretty bad effort, is a line of best fit that should look something like that, perhaps a bit smoother. So take your time with that. It should have been 3 relatively straightforward marks if you took your time there. Now you were then asked to work out the mean rate of reactions for small calcium carbonate chips. And that's the one that's been plotted for you. And so again, you just have to read the graph at 20 seconds and 105 seconds. So 20 seconds is here. So you should go up to this point here, and 105 seconds, which is there, and you've got to get it exactly right. So you get a mark for identifying that that's 0.0038, that's the top value here, or wherever it was I just pointed to, and 0.0014 for that one. So you get 0.0038 and 0.0014. So that's how much gas has been released at those 2 different time points, and the change of time is obviously 105 take away 20. So rate of reaction is the change in either moles or volume or mass per unit time. So per time, divided by time, in other words, and so that's 85 seconds, okay, or 105 take away 20. And so you had to get those 2 for the mark. You have to do that sum for the mark, or show that sum for the mark. And some of you did this without showing your working, which was a bit disappointing. And then you get the mark for the sum, which is 2.8 times 10 to the minus 5. Some of you wrote it out as the full decimal, which is okay. Naught, 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 naught. You're going to get the right number of noughts. That should have been that. And the units are whatever it is in y per whatever it is in x, if you like. So it's moles of gas per second, okay, and that's that one. A mole, number of moles per second would have been fine if you wrote it out longhand. 8.3, the student calculated that large calcium carbonate chips reacted more slowly. How do the student's results show that conclusion is correct? There's loads of ways of getting that mark. So the most obvious one is just to simply comment on the graph. So the line for the large chips is less steep. That's, to me, the easiest one. So large chips less steep, so it's obviously slower. Or you could actually be more detailed and say a smaller number of moles of gas is given off in the same time. So pick a time point like 50 seconds, say, and less gas is given off at that time point. And that's true for every time point on the graph. Or you could simply say more time is needed to collect the same number of moles of gas. So you come up with a fixed number of moles of gas, 0.003 for example, and more time is needed. Oops, you can't see it, but you get the idea, hopefully. All right, so most people got that mark actually. That might be the end. One more. That was on the page. Right, so question 8.4 was around simply doing a little bit of maths, and actually loads of people got 2 marks for this. If it's asking you to do it in a whole number ratio, surely you're going to have to give that for a mark, right? So the surface area, to work out the surface area of a cube, you need to work out the area of one face and then times that by 6. It's a cube, so 0.5 times 0.5 would be a face. And then there are 6 faces, so times that by 6. That comes to 1.5. And the units for that, of course, centimetres squared, so you didn't need that for the mark. And the volume is one side times the other side divided multiplied by the depth, so it's 0.5 times 0.5. 0.5 or 0.5 cubed, some people wrote, and that comes to 0.125. Units are centimetres cubed then, because it's a volume. So you got 2 marks so far. Loads of you just wrote that down, and you had to get them the right way around. So it had to be, I was going to write it up here to make it clear, 1.5 to 0.125. But how do you turn that into a whole number ratio? The easiest way to do that is do the big number divided by the little number, or divide them both by the smallest one. So if you divide 1.5 by 0.125, you find that it's 12 to 1. So if I divide them both by the smallest, you get 12 to 1. So that was the answer for 3 marks. And then imagine you had a larger calcium carbonate cube, 5 centimetres, and it asks you how the surface area to volume ratio changes. Many of you correctly said that it gets smaller, but it doesn't get a mark. You need to say that it's 10 times smaller, or decreases by a factor of 10. And you might want to just convince yourself there by doing the maths, if you like. But of course, it's 10 times smaller, and that gets the mark. I have to say that. Right, that's it. That's so long.